Hi friends, today we will study organic chemistry. It is the short revision of the organic chemistry as class 10th. So let's start. Branch of chemistry dedicated only to the study of carbon and its compound is called organic chemistry. Carbon has a unique tendency of catenation. It binds with itself via a series of covalent bonds. This is the basis of organic chemistry. The bonds that are formed by sharing electrons are known as covalent bonds. Characteristics of organic compounds are they are covalent compounds of carbon. They can exist in the three states solid, liquid, and gas. They are soluble in organic solvents. They are poor conductor of electricity. Organic compounds can be classified into the following categories. They are open chain of aliphatic compounds, closed chain or cyclic compounds, carboxylic or homocyclic compounds have ring comprising only of carbon atoms. Heterocyclic compounds contain only elements beside the carbon in the ring. Now the organic compounds are divided into two parts, acyclic or open or cyclic or closed chains. And closed chains is also divided into parts, that is homocyclic and heterocyclic compound. And homocyclic is divided into alicyclic compound and aromatic, and then aromatic is divided into benzoate and non-benzoate compounds. Acyclic or open chain compounds consist of straight or branch chain compounds. Alicyclic is closed chain or ring compounds contain carbon atom joined in the form of ring. Homocyclic. In some rings, heterocyclic atoms other than carbon are present. Benzenoid aromatic compounds include benzene and other related compounds. Non-benzenoid compounds do not contain benzene ring. Functional group, an atom or group of atoms joined in a specific manner which is responsible for the characteristic of chemical properties of the organic compound. For example, alcohol, aldehyde, etc. Homologous series, a group of a series of organic compound, each containing a characteristic functional group. Successive members differ from each other in molecular formula by CH2 unit. Now hydrocarbons. The compounds made up of only carbon and the hydrogen are called hydrocarbons. The compounds of carbon that contain only single bonds among carbon atoms are called saturated compounds. Compounds containing double and triple bond among carbon atoms are called unsaturated compounds. If the hydrocarbons are saturated like methane and ethane, they are called alkanes. If they are unsaturated, they are called alkenes containing double bond and alkanes containing triple bond. Aliphatic compounds, the organic compound that have a straight chain or branch chain structure. Example, methane, ethane, propane, 2-methyl propane, etc. They are classified as alkanes containing only single bonds. The general formula is CnH2n plus 2, where n is the number of atoms. Alkenes contains at least one double bond. General formula is CnH2n, where n number of carbon atoms. Alkynes contain at least one triple bond. General molecular formula of alkenes is CnH2n minus 2, where n is the number of atoms. Alicyclic saturated hydrocarbons. Saturated organic compounds in which the carbon atom from a closed chain. Aromatic compounds, organic compounds that contain a ring system and have characteristics order and fit. First member in benzene. Structural isomerism. Organic compounds which have same chemical formula but different in the structure are known as isomerism, and the phenomena is known as isomerism. For example, 2-methylpropane is the isomer of N-butane. Types of structural isomerism: chain or skeletal nuclear isomerism. Difference in the structure of the carbon chain that forms the nucleus of the molecule. Position isomerism: difference in the position of the functional group, the carbon multiples bonds of a substituent group. Functional group isomerism: presence of different functions groups. Metamerism: different in the number of carbon atom at the other side of the functional group. Now the functional group, carbon also forms covalent bonds with oxygen, nitrogen, sulfur atoms. Presence of any of these elements is a compound confers specific properties to the compound. A group of atoms that imparts a specific properties of the hydrocarbon is called the functional group. Some functional group of the carbon compounds are shown in the given table. The heteroatom chlorine, bromine, halo, chloro, bromo, alcohol, aldehyde, and ketone. These are the halo, that is chloro, that is Cl, bromo Br, alcohol OH, aldehyde CHO, ketone less than C, oxygen, carboxylic acid COO and H. Homologous series. A homologous series is a series of carbon compounds having different number of carbon atoms but containing the same functional group. Alkane's general formula is CnH2n plus 2 occurs. Methane is a main constituent of Mars gas. Methane is exhaled by animal or fed by the food containing cellulose. Methane is found in the intestinal gas of human, and the methane is found in cavities in coal. prepared by reduction of unsaturated hydrocarbon, hydroreduction of alkyl halides, Wurtz reaction, and deoxyrization reaction, Klopp's electrolysis. Properties: the properties of these are non-polar, colorless, and odorless. Hydrophobic combustion reaction produces carbon dioxide. Controlled oxidation converts them to group alcohol, aldehydes, and carboxylic acid. Undergoes isomerism in the presence of AlC3 and HCl. Aromatization reaction takes place at 773 K to 10 to the power 20 atmospheric pressure in the presence of oxide of V, M, and Cr supported over alumina. On heating to the higher temperature, higher alkanes decomposes into lower alkanes or alkynes, pyrolysis and cracking. Alkyls halides can be prepared in the substitution reaction of alkanes. Uses: the preparation of the acetylene of the formaldehyde are the chloromethane and tetramethane. Domestic fuel preparation of useful solvents in dry cleaning. And the alkenes. General formula is CnH2n. Alkenes are unsaturated hydrocarbons containing at least one double bond. Carbon double bond in alkanes consists of one sigma bond and one pi bond. Prepared by partial reduction of alkane, dehydrogenation of heating alkane halides with alcoholic KOH, dehalogenation by reacting vacuum dihalides with zinc metal, dehydration of the alcohol using concentrated sulfuric acid, and heated by aluminum oxide. Properties: colorless, odorless, insoluble in water, and fairly insoluble in polar and solvent. Undergo addition reaction: addition of hydrogen to form alkanes, addition of halogen to form dihalides, addition of hydrogen halide to form alkyl halides, addition of H2SO4, addition of water, oxidation of alkenes with the base Pz converts them to vicinal glycols, acidic KMnO4 and acidic K2Cr2O7 oxidize them to give a ketone or acid depending upon the nature of alkenes. Undergoes ozonolysis of the form of aldehydes, polymerizes at high temperature in presence of suitable catalyst. Undergoes combustion to form a large amount of heat. Uses: the manufacture of synthetic chemical, polythene, raw material, and detergents from wrapping of fruit producing oxyethylene. Now alkynes. General formula is CnH2n-2. They are named a corresponding alkenes replacing the ANE by suffix "-n". Each carbon atom of ethene have two hybridized orbital. Preparation of ethanes from calcium carbide from vaccinal dihaldes. Properties: that is colorless, odorless, weakly polar, immiscible in water. Hydrogen attached to the triple bond of the acetic undergoes addition reaction. Addition of dehydrogen, addition of halogen, addition of hydrogen halides, addition of water. Undergoes linear and cyclic polymorphism and the source oxidation reaction. Undergoes oxygenalysis and produces oxygen sheets. Uses: oxygen acetylene and the welding at a high temperature, illuminate and oxyacetylene lamp, ripening and preservation of fruits, manufacture of several products like polymers, artificial rubber, oxalic acid, acetaldehyde, acetic acid, etc. Methanol CH3OH. Preparation: earlier produced by destructive distillation of food, nowadays produced by catalytic hydrogenation of carbon monoxide. Properties: colorless liquid, boiling point is 37 Kelvin, and highly poisonous. Small quantities cause blindness and large quantities cause even death. Uses: as a solvent, it is present at varnishes, and the preparation is formaldehyde HCHO. Now ethanol C2H5OH, also known as Sprint and grain alcohol. Preparation by fermentation of molasses or hydrolysis of alkyl halides with dilute hot alkalis by hydration of ethane and using concentrated H2SO4 as 30 centimeter atomic atmospheric pressure, as 3PO4 at 300 degrees Celsius to 60 atmospheric pressure. Properties: that is liquid and boiling point 351 Kelvin, pleasant odor and inflammable, very good conductor of organic solvent, reacts with sodium, undergoes dehydration and form corresponding alkene. Combustion reaction produces carbon dioxide, water, and heat. Oxidized to corresponding aldehyde and carboxylic acid by acidified the K2H2SO7. Undergoes esterification reaction with the carboxylic acid. It reacts with the phosphorus halide to form alkene halides. Now the uses: as a solvent in a manufacture of paint, and the number of carbon compounds, denaturation of alcohol, making commercial alcohol unfit for drinking by mixing compounds like copper sulfate, pyridine in it. Dental alcohol, addition of poisonous substance like pyridine, methyl alcohol to pure ethanol for making to it unfit for consumption. Also calls methyl aspirin contains 5% of alcohol uses of industrial purposes, and the simplest alcohol liquid prepared by super distillation contains large portion of methanol fatal for human consumption used for the solvent for paints and varnishes. Acetic acid, common name of ethanoic acid, CH3COH. It dilutes the solution in water in known as vinegar. Preparation of acetic acid is done by the following methods: oxidation of ethanol or ethanol using acidified potassium dichromate solution from acetylene using concentrated H2SO4 and H2HgSO4. Now the properties of acetic acid as follows. It is colorless, pungent, smelling liquid miscible with water. It is weak acid. The reaction of carboxylic acid with an alcohol to form a ester, that is known as esterification reaction. Esters react with the presence of an acid or base to give a back alcohol and carboxylic acid. This reaction is used to preparation of soaps and it's known as saponification reaction. Ethanoic acid reacts with the sodium hydroxide and the form a salt, sodium ethanoate, and water. Carbonates and bicarbonates are also basic in nature and react with ethanoic acid to form salt, water, and carbon dioxide. Ethanoic acid reacts with phosphorus compounds like chlorine, chloride, and oxide form a corresponding acid derivate. Uses manufacture of polyvinyl acetate, cellulose acetate, and vinegar as organic solvent. Thank you. This was the video of a short revision of the organic chapter. Hope you liked. Please like, share, comment, etc. Thank you and have a nice day. All the best for your exam.